We are back once again. It is daily LeetCode. It is day 125. So 100 days, 125 days of suffering. Many more to come. We are a bit strapped for time today. Schedule, it just needs some work. We're a bit strapped for time. So we're just going to have to jump right into it just because I'm a little bit strapped today. That is unfortunate, but I feel like sometimes it'd be like that. But I will make sure to answer the comments tomorrow, as well as add a little bit of extra spice and everything nice. So I'm just going to jump into the problems, and we're just going to continue with the problems for today. Also, make sure to join the Hyperbolic Coding Chamber. This is a legendary coding chamber that is expanding very, very rapidly. We also have to shout out Luminous yesterday. He just scored a Amazon internship, so love to see it. Can't believe it. But that is the spoil. Those are the rewards. To the victor goes the spoils, and Luminous was the victor. So always flames to see, especially in the Hyperbolic Coding Chamber. So you're going to want to join specifically to use the GPT-3 instance that he was allowed to use. You're going to want that secret code, so you're going to want to join to make sure that happens. But we have some problems to do today, and we're just going to continue as usual. So we're doing easy by frequency. We're doing the transpose matrix. It's already here. Next greater element, reverse words in the string 3, and remove palindromic subsequence. So transpose matrix. So let us jump into it. So I think we said for this one we could start with an empty matrix and copy the values over and swap the rows and columns. I think we're transposing the matrix, so we're given a 2D integer array matrix, and we want to return the transpose of the matrix. The transpose of a matrix is the matrix flipped over its main diagonal, switching the matrix's rows and column indices. Right, so here we have a symmetrical matrix, and the rows are 2, 4, -1, -10, 5, 11, 18, -7, 6. We transpose it, and the rows become the columns. So since the rows become the columns, it's possible that with an asymmetrical matrix, m is equal to matrix.length and n is equal to matrix_by.length, it doesn't seem that they have to be, we don't have an m is equal to n, so we don't actually know. But usually, even if we have more rows, than columns, so if we had 4 rows and 3 columns, we should end up with 4 columns instead. So we can actually change the shape of the matrix. So to do that, I think we just wanted to iterate over the matrix as you would per usual, with iterating over the rows and the specific columns, where here we want to iterate over the columns and then add the items in the rows. So each row item here would become, each column item here would become a row item in a particular array. Let me just think this a little bit further. Start at 2. We'd use the column we'd use R as its column. So I think we could make this work, but I want to think it through before I start programming, so I don't just start filling it in with my mind. I guess I wanted to visualize the code before I wrote it. We're going to be iterating through. We're going to have row equals 0, row is less than, matrix.length, row plus plus, inside we'll have the column, which means we'll finish finish all the elements in a row, then go to the next row. Which means the row we'll start at will be 0. But if we iterate over 2, 4, 1, how do we get those values into those 3 separate arrays? So the column 0, 1, and 2 will have to be swapped for the row 0, 1, and 2. And the row here transpose of the matrix is the matrix flipped over its main diagonals between the matrix's row and column indices. 2, 4, negative 1, 2, negative 10, and 18. So we do 2, 4, negative 1, which would be iterating over the column's indices 0, 1, and 2. From there, we'd like to place those into 3 separate arrays. Those 3 separate arrays would be arrays 0, 1, and 2. But the specific position will have to be the row. So it'll always just be Alright, so basically the row indice is going to correspond to the column indice. So we would say copy sub column let's just say we're at 4. Let's just say we're at negative 10, 5, and 11. This would be row 1, column 0, which means in copy this would actually be row 0, the 1th element. I feel like we can just write this out, but I wanted to visualize it first because I think when I write it out, I don't ingest the problem that deeply. Two, 4. We'd have copy sub let's be in the next one, so we'd use the row. We wouldn't use the row. Yeah, we would use we would use three arrays, 2, -10. Two, 4, -1. Two, 4, -1, which means the rows and the columns column, but the column would just be 0. You want to access the second item, which would just be the row, which would become column. Then we'd say I think we can just write a solution to this, but I really want to visualize the solution. But I don't think that is going to be working. So we have R and C, and we pretty much have T is going to be the transpose of the matrix, which we return. Let me see if this is even visible. So T is the transpose of the matrix, which we return. And so before we can do that, we'll need to push on, or we need to turn the number of rows. So the number of columns here, right, is going to become the number of rows. So our environment still keeps freezing. So we're just going to do t dot push an empty array for each column. And I think we can actually just simplify this whole thing by doing matrix sub 0 dot length. I think we should always have at least one row. And then from here, we just have to push the values on, I believe. So we'll have the row, for example, 2. We'll have the row which is 0. For example, if we're iterating through this, like 2, 4, -1, -10, 5, and 11, we'll have access to 2. We want 2 to go downwards, so we can't just push onto the array because that would be creating another row. What we'd like to do is say that T sub C, we know that the row has to change each iteration, so I feel like the C has to become the row. Now it'd be 0. Then we'll set R equal to matrix sub R sub C. We actually didn't. We didn't set up the column in this, the specific spaces in the columns, because we just have 4 rows created, or 3 rows created, so we'd have to push the elements on. I think this would work. So we'd start at 2, then we'd say, okay, T sub 0 should be the first row, right? Sub R, which would also be 0, push RC, which would be 2. Then row would still be 0, column would be now 1, and we'd say, okay, well, T sub C, which would now be 1, so now we're in row 1 with, it's kind of confusing because the rows and columns are swapped, but in the secondary matrix, the columns and rows are swapped, so we'd be at row 1 with a column of 0, so we'd push RC, should be 4, and we'll try -10 here. This would be row 1 starting at 0, so we'd say C, which is 0. So we start at row 0 with r being 1. And so we're just going to say t sub c sub r dot push -10. I think this should work. Undefined local variable or method C. Yeah, I feel like we knew that this would work, but I wanted to visualize the code, and while we got the answer, it doesn't really feel like progress was made. So I wanted to be able to visualize the code before I wrote the solution. But that we got like halfway there, but just got confusing even explaining it. But I would say the time complexity, I don't know if we count the output of the transpose of the matrix, but if we don't, I would say constant space maybe, but if we do, maybe m by n or n by m, same thing. I think m by n space, and then it's just m by n time as well. Yeah, I think I just wanted to extract more out of the problem by visualizing it, but that is unfortunate. So we will try this one. The next greater element of some element x. The next greater element of some element x. The next greater element of some element x in an array I don't know what this means. You are given the next greater element of some element x in an array is the first greater element that is to the right in the same array. You are given 2 distinct 0-indexed integer arrays. nums1 and nums2, or nums1 is a subset of nums2. For each 0 for every element in I, in num sub I, find the index j such that num sub I equals num sub j, and determine the next greater element of nums2 return an array ands of length nums1.length such that ands I is the next greater element as described above. That is a lot. So you have nums1 equals 4, 1, and 2. Nums2 equals 1, 3, 4, 2. The next greater, and then nums1 is a subset of nums2. Looks like the order can vary. And they want us to return the next greater element of num sub I such that num sub I is equal to nums2 sub j, which is equal to 4, but the next greater element doesn't exist, so we'd put -1. We find 1 and 1 here, and the next greater element would be the next greater element, which would be 3. Go to 2, the next greater element would be -1. The next greater element for each value of nums1 is as follows. Greater element is 3. 1 is equal to 2 comma 4, nums 2 is equal to 1, 2, 3, 4. Nums 1 is equal to 2 comma 4, and nums 2 is equal to 1, 2, 3, 4. So 1 is equal to 2 comma 4. Nums 1 dot length is less than or equal to nums 2 dot length, and 0 is less than or equal to nums 1, 1. Nums 1 sub I, nums 2 sub I is less than or equal to 10 to the 4. All integers in nums 1 and 2 are unique. So I think you could just brute force this one for each element in nums 1. First you would find nums 1 sub I in nums 2, and then look for the next greater element. I think that would give us time complexity of n squared, which is probably still acceptable. Our environment is frozen once again. I think maybe we'll have to stop doing our problems on Mac, or I think our OBS settings are just don't make any sense. I don't know. We'll say const and is equal to an array. Do nums 1 dot length. We'll say now first we have to find the number, and once we find the number, we want to find the next greater. So maybe we could have a variable called doppel idx, which would be its doppelganger idx. And then we'll say if nums 1 sub I equals nums 2 sub m, we'll set doppel idx equal to m. And then we'll say if nums 2 sub m is greater than nums 2 sub doppel idx, this would ideally be the number that's greater than it, nums 2 dot push m. And after this round, once we do the break, which end about here, we'll say if doppel idx equals -1, which means we never found the doppel. Oh no, we had to find the doppelganger. We never found one that was greater Never found one that was greater. What is going on? So from here, I don't think we actually need another variable. I think we can just say if ans.length. So presumably if we found one that was greater than doppel, then its doppelganger index, then we would have pushed that number on. If we didn't, we wouldn't have pushed the number on. So if, for example, we're at index 2 here, or let's just say we're at index 2 here, at the end, we start from m, actually we want to start at m is equal to I. Actually, no, m is equal to 0. Then as soon as we find the doppel index, should be 2, there's nothing ever greater than it, so it ends, and our array would actually be, our answers.length would actually be 2 when it should be 3. So at this point, I would actually be equal to 2. So if ans.length if ans.length does not equal I, answer.length does not equal I. Answer.length does not equal I. Answer.length, the answer's length would be 3 if we found it, and I would actually be equal to 2. So if answer.length does not equal I plus 1, then we want to push on -1, I think. Try for this one. So we start at index 0, doppel index equals -1, then we iterate over all the elements in nums2. We say if nums1 sub I equals nums2 sub m. So we're looking for 4. We don't find it here until we find it here at index 0, 1, 2. So doppel IDX equals m. Then we say if nums2 sub m is greater than nums2 sub doppel IDX, it's not, right, because they're the same index. Then we go to the next index. Also want to do doppel IDX is positive, basically. Now we check 2, and 2 is not greater than 4. And we should say, okay, if answer.length, which is still 0, does not equal I plus 1, which would be 1, then we're going to push on -1, so we do. Then we look for 1's doppel. I think this should work. Does not work. It works for case 2, barely. how are we getting -1 here? So we're saying we find -1 for 4 as the next greater, and then we go to 1. So we say, now we look for 1, we say dot.idx equals -1. Dot.idx -1, and num sub 1 sub I, which is 1, so go to num sub 2 sub m, and it is, we say if dot.idx, which is now positive, and nums 1, which is now positive, and nums 2 sub m, which should be equal to 1, which is nums 2 sub 1 should give you 3. Nums 2 sub m is greater than nums 2 sub dot.idx. Oh, I think I see the issue. If dot.idx messes up when dot.idx is equal to 0. So I think we just want to say dot.idx is greater than or equal to 0. Maybe? Oh, it's okay. So it looks like this would be I feel like this is like n squared in the worst case. Is what if nums 1 is all 1s and nums 2 is also all 1s? Or maybe not n squared, maybe it's just nums 1, which would be n times m. Yeah, I think this would be n times m. Also, all integers in nums 1 and nums 2 are unique. Could you find O of nums 1 dot length? It's nums 2 dot length solution. Could we find an O of nums1 dot length and nums2 dot length solution? I feel like we could. Maybe, I think like the key might be here that the integers in nums1 and nums2 are unique, since nums1 is a subset of nums2. Maybe we could save the indices in a map 1, 3, 4, 2. We've run out of time, so I have to call it. We will be back once again tomorrow, this time with regular schedule length, so about an hour, and we're going to look through the comments. So, yeah.